Alright, we're on to page 13 of Notes 2. Still dealing with Taylor polynomials, except this time we're going to kind of use them for some stuff. So let's take a look at the problem. So we're dealing with sine of x, and we want to center at 0, so it's really a Maclaurin polynomial. We want the third degree Taylor polynomial. It says to find it, but we're just going to write it down because we already know it. We're going to integrate that from 0 to 1/2 and use that as an approximation of the integral from 0 to 1/2 of sine of x, and then compare the answers. So probably got to start off with writing the polynomial. So sine of x I have memorized. It's odd, so odd powers. So x minus x cubed over 3 factorial, that's third degree. So when we say third degree here, we mean something that an Algebra 2 student would look at and be like, that's a third degree polynomial. So there you have it. Now I'm going to integrate that from 0 to 1/2. So the integral from 0 to 1/2 of sine of x dx is approximately the same as the integral of our Taylor polynomial. It's one of the ways we can use them. And it's way easier to integrate a Taylor polynomial because all you need to do is reverse the power rule, which is great. So it's plus 1 times the reciprocal. Here I write 4 factorial because I end up doing 3 factorial times 4, which is the same as 4 factorial. And then to the fourth from 0 to 1/2. When I plug in 0, obviously it just goes away. So this gives me 1/2, and then 1/2 to the second, minus 1 over 4 factorial, and then 1/2 to the fourth, which, I don't know why I decided to do so much of this by hand. I get this, so finally I get 47 over 384. That's my approximation. I don't really know what that is as a decimal though, so calculator gave me this value. And now let's compare it to what we get on a calculator. So what I did was I just used my Inspire to evaluate both integrals. And here's a screenshot. You can see to 3 decimal places they're exactly the same. If you round to 4 decimal places, they're still the same. And after that we start losing our accuracy. But it did a really good job. And I'm not sure how you would go about approximating this otherwise. So this is a really nice way of approximating. I mean, obviously you could use Riemann sums and things like that. But this is a really nice application of Taylor polynomials. So let's do one more and then call it quits on these notes. So here is the problem. 6th degree Maclaurin polynomial. So that's going to be centered at 0. For sine of x squared, and then use it 0 to 1/2, blah, blah, blah. Okay, so I need sine of x squared. So we start off by writing sine of u. It's approximately u minus u cubed over 3 factorial. Since I'm going to sub in x squared, I know that if I stop at cubed when I do squared to the third, it gives me to the 6th. So I know that I'm done there. Now I do the substitution, create the composition, whatever you want to call it. That gives me x squared minus x to the 6 over 3 factorial. So now what I really want to do is integrate that. So the integral that I'm looking for, 0 to 1/2 of sine of x squared, is approximately the same as the integral from 0 to 1/2 of my Taylor polynomial, or my Maclaurin polynomial in this case. Ooh, I forgot a dx. Oh well, we'll live with it. I used a calculator to get that because it seemed like it'd be really annoying. And then let's compare the values. So here's a screenshot of what I got when I compared the values. So the integral from 0 to 1/2 sine of x squared was 0.041481, and then the integral of our polynomial from 0 to 1/2 also gave me 0.041481. So they're actually the same out to 6 decimal places, possibly more. I didn't check. But this is a really good use of these. So I hope you found this helpful, and good luck.